All right, so our project is about predicting the severity of diabetic retinopathy. So we're trying to detect how severe a condition is based on images of the eye. And here is a sample of the image that we're going to be using. So all the 300,000 some images look like this. So here's our problem description. Diabetic retinopathy is a diabetes complication that affects the eyes. It's caused by damage to blood cells in the tissue behind the retina. So this impairs vision. It can make your vision blurry. It can make you partially blind and see random floating objects in your eyesight. So we want to detect how severe it is based on images taken by a machine. So 0 being the least severe and 4 being definite. So our goal is to train a multi-classification problem or multi-label model to predict these 0 to 4 values. Our motivation is to one day help diagnose this condition quicker, because this condition takes hours to days to diagnose, and based on the severity, we can give doctors and patients an idea of how severe their condition is and how they can improve upon it. So here is a slide a little about diabetic retinopathy. So it's considered pretty rare to have. It's common for people above the age of 40, and it's for people who have type 1 or type 2 diabetes. It's an incurable condition but can be slowed down with medication, but it's always going to keep getting worse. And imaging is always required when getting a diagnosis. So this is actually very helpful to us, because that means our algorithm would be useful in every single case of trying to diagnose and assess how severe this condition is. So right here are pictures of the imaging devices that are used. So these images are the ones that are being directly fed into our algorithm. It's a machine that goes around your eye and lights your eye really bright and takes an image. And these images are all cropped to the same size. So these exact images from these machines are directly fed into our model. So for the data, we got the data from kaggle.com, and it's a total of 7 gigabytes. And there's 2 files, the resize train 15 images and the resize train labels 15. So each of these are 2 different files, so we have to match each image name in the labels file with the image in the train file. And all the images have already been cropped for us, 1024 by 1024 pixels, so we did not have to self-crop or feature reduce anything. So that is our data. And for the prediction, we use something called Deep Image Featurizer from the SparkDL library. Basically what Deep Image Featurizer does is it fits each image into a convolutional neural network called Inception v3. And that pretty much converts each image into a numerical feature vector. So we use the Deep Image Featurizer to convert each image into a numerical feature vector. And if you look at the bottom in the picture, the features column, you'll see that feature vector right there. So after we got the feature vector, we wanted to classify it into 0, 1, 2, 3, or 4. So we fit it into a logistical regression model to try and find the best prediction for the specific label that we were looking for. And for the results, since we only had a trained data set and we didn't know the ground truth labels for the test data set, we basically split the trained data set into 70% and 30%. We used 70% to train the model and 30% to test the model. And when we finally found out the accuracy, it came out to become 96%. And we were able to predict the diabetic retinopathy severity 96% of the time. And on the bottom left, you can see the sample results. The left column is the prediction and the right column is the expected label. And as you can see, there's a lot of zeros because this disease is very rare. So there's going to be a lot of zeros and our data is very unbalanced. But you can see we predicted the 1 correctly, we predicted the 4 correctly, but we missed out on the 3 and the 2. But other than that, it was pretty solid, and that's how accurate our model was. And that's our works cited. Thank you.